Greetings. In the previous envelopes tutorial, we created an ADSR envelope with fixed parameters. We defined the envelope parameters as constants, and if we wanted to try out a different value, we had to recompile and run our example. This is great if we know what we want our values to be. Sometimes, however, we don't really know what the value should be, and we need to find it by ear. What we can do in HappyBrackets is create dynamic controls that allow us to monitor and make changes to values while the code is running. First, create our new composition by going to the source folder and making a new HappyBrackets sketch. Name the class MyControlledEnvelopeGenerator. Let's fast track through these first steps because we covered these in the envelopes tutorial. Create your initial values as class variables. Create your basic wave player and change the audio volume to an envelope. Create the segments. Create your clock timer with a duration of 3000. Move your basic wave player and envelope segments into the clock. Now play the example to make sure that it works. Now we're going to make a control to change the attack volume. At the line below end clock timer, begin to type float text control. Note that this is a live template. You'll be prompted for some parameters. The first parameter is the control name. Type attack control volume. Next, you'll be prompted for a name that you want to have displayed. Type attack volume. Finally, you'll be prompted for an initial value. Type in attack volume, which is the class variable that you defined earlier. What we have done is created a text box control whose name is attack control volume. This will display as attack volume. We set its initial value to that we defined as attack volume. After you press the enter key, IntelliJ will place you where you need to type some code. We'll write attack volume equals control value. What we are saying is that we want our attack volume variable to be set to what the control value is. Run the code. You'll hear the sound envelope played every 3 seconds. Change the text in the control to 1 and press enter. You'll notice that the attack volume is louder. Sometimes we may want to use a slider control instead of a text box. Let's do this with the decay volume. Type float slider control. For the control name, type decay volume control. For the name, type decay volume. For the initial value, type decay volume, which is the value we defined as our class variable. You will now be prompted for minimum and maximum values. These two parameters are what we want the maximum and minimum values of our slider to be. Put a minimum of 0 and a maximum of 1. Inside the dynamic control code, type decay volume equals control val. Run the code. If you move the slider to the minimum, you will hear the envelope play its attack, but then go to 0 and then move up to the sustained volume. If you move the slider to maximum, the volume will go higher during the decay and then move down to the sustained volume. Sometimes you want to display both text and a slider to control the value. Let's do this with the sustained volume. Move down and make a new control by typing float buddy control. For the control name, type sustained volume control, and for the name, type sustained volume. Use sustained volume as the initial value and use 0 and 1 for minimum and maximum. For the control action, type sustained volume equals control val. Run the code. You can see that changing the slider or the text box will change the value. We can also make controls for integers, strings, triggers and Boolean values. Let's control our durations. Also, add a control to set our clock speed. We need to add a glide to set our clock duration. Just below our clock definition, create a glide object and use the clock interval as its initial value. Now make our clock use this object to define its clock interval. Now create a control to adjust the speed. We can also display values in dynamic controls. Let's say we want to display the total duration for our envelope, which is attack duration plus decay duration plus sustain duration plus release duration. We want to use this calculation in a few places, so we'll just make a function to return its value. If I decide to add another segment, I only need to change the calculation code in one place. Let's call this function getTotalEnvelopeDuration. Create a new control called envelope duration before all the duration controls. For the initial value, type getTotalEnvelopeDuration. Now inside each duration control action, type envelope duration, set value, getTotalEnvelopeDuration. Run the code and change the duration parameters. You can see that the envelope duration is being updated with the new value. Let's make a few more changes. Let's start and stop the clock with other types of controls. First, let's create a Boolean control. This will display a checkbox that will pause the clock when it's checked and restart the clock when it's unchecked. Type Boolean Control. For the control name, type Pause Clock Control. And for the name, type Pause. And for the initial value, put False. Inside the listener, type Clock Pause Control Value. We will pause the clock based on the control value inside the listener. Run the code. You'll see that checking and unchecking the control will start and stop the clock. Next, we'll make a text control. Type Text Control. For the control name, type Start Stop Text. And for the name, type Start Stop. And for the initial value, we'll just leave it blank. Inside the listener, we will start the clock if the user types Start and stop it if they type Stop. Note that we're setting the value of the Pause Clock Control object. When this is changed, it will call the listener for the Pause Clock Control object, which will start or stop the clock. Finally, we will toggle our clock on and off with the trigger control. Type Trigger Control. For control name, type Start Stop Trigger, and for the name, type Start Stop. You will notice that there is no initial value because a trigger has no value. Inside the listener, we will toggle the value of the Pause Clock Control object. Note that we need to cast the value to a Boolean before checking it. Run the code and check that it works. Typing start in the text box starts the clock, while typing stop stops it. Likewise, pressing the send button next to the start stop trigger toggles the state of the clock. Now that we've seen it in our simulator, let's see what happens if we download it to our device. You will see that the control displays on the screen. If the controls do not display, right-click the B button and select Show Controls. Also, we can make it so it's always on top. So that's it. We've seen how we can create dynamic controls that we can use to modify internal parameters inside our composition without requiring us to recompile or re-download the composition.